won't do it. I'm the guy with notes. I'm the guy who's... This one's a little longer. All of a sudden, I just forgot the word.
Good day, members of the Armed Forces community. This is a very scientifically complicated topic, but we are going to try and make it as clear and concise as possible, since it is important that you understand its overarching significance. This information might just prevent weapon system failure, or worse, national infrastructure instability. We have condensed the essence of the CPAC workshop so that this brief will hopefully guide you in the development of a corrosion prevention action team and the corrosion prevention control plan. At this time, I'm going to turn the briefing over to retired Air Force Colonel Michael Carpenter and retired Air Force civilian Dick Kinsey. Gentlemen.
Thank you, Dan.
Hey, Dan, what a great introduction. Really appreciate that. I guess you're wondering, first of all, why are you here today? Why is it so important to learn about corrosion prevention and control?
Well, let's start off with one big figure. Over $20 billion annually to the Department of Defense.
That's what the maintenance is for corrosion prevention and control. And that's as a minimum. Arguably, it's about 20% of all the maintenance that we do on all of our systems and all of our infrastructure. 20%, 1/5 is corrosion. So it is an important subject. And we're not the only ones that recognize that. The numbers speak for themselves, but Congress has enacted legislation to provide focus on this problem as well. And so it's up to us to make sure we follow their lead and the department's lead as we've put together policies and within the department, directives and instructions to again emphasize the importance of corrosion prevention and control in our systems. We can't just play lip service to this. It's an important problem. So we're here to help you get into compliance with the instructions, give you the tools that you need to do that, and also to provide you the practical solutions that are critical to the success of your program in corrosion prevention and control. Well, how about let's turn it over to you guys now for some questions. You there in the front row?
What tells me I should have a corrosion prevention and control program?
Well, I already talked about a couple of things, but allow me to elaborate some on that. The actual legislation that the Congress passed was Title 10 USC 2228, and it basically directs us in fairly specific ways how to go about establishing corrosion prevention control as an emphasis area for the Department of Defense. They're looking at the Department of Defense to be the leader within the federal government and actually through industry to emphasize corrosion prevention control in our systems and infrastructure. Now, the department has stepped up in a number of different ways to that mandate. The first one is that in our acquisition Bible, the 5000.1, the Defense Acquisition System Directive, we have placed in there the requirement to address corrosion prevention control in our programs. 5000.2 has been and will continue to be changed to increase our emphasis on corrosion prevention and control. The DFARs that we have require now that in acquisition strategies and acquisition plans that corrosion prevention control be part of those for ACAT 1 programs, but it's a great practice for any program. Our friends in the maintenance side of things have also emphasized the corrosion prevention and control and the importance of that in changing DoD Directive 4151.18, maintenance of military materiel. Now, we didn't stop there. DoD Directive 5000.67, prevention and mitigation of corrosion on DoD military equipment and infrastructure, specifically goes to in-depth all the requirements of what we have to do on the corrosion prevention and control programs. And lastly is the Corrosion and Prevention Control Planning Guidebook. In that is just chocked full of knowledge, information, lessons learned, best practices for how to establish and run a corrosion prevention and control program. In the guidebook, there's a diagram that kind of outlines how that particular document is put together. And in that, it kind of shows two key aspects of a corrosion prevention and control program. First is the program management side of things that integrates into our integrated logistics support program. The other side is the technical and design considerations that you need to take into consideration as you're developing your system. So now let me take those two separately. Under program management, it basically is how are you going to set up your corrosion prevention control program. Key aspects of that are things like the corrosion prevention action team, the people that are actually driving the corrosion prevention control program. How do they act? Who are they? When do they get involved? What's their membership, etc. It also talks about the contractor corrosion team, kind of the counterpart of the CPAT, only on the corrosion, on the contractor side. And then it also talks about the corrosion prevention control plan, which kind of governs it all on the direction it's going to go. Under that program management side, there's also some discussion about how to integrate with your integrated logistics support plan. You've got to have those two working together in order for it to really be an effective corrosion prevention control program. Now, the other side after program management is the technical and design considerations. Now, in the technical considerations, things like corrosion variables come into play. What potential solutions you have for the corrosion problems that you might run into. For those solutions, there's going to be impacts to the system. Understanding those impacts is pretty important, both positive and negative. And then bringing the service laboratories into your solution set so that you come up with some technical solutions to some of your problems from some of your closest SMEs. Under the design considerations, things like material selections would be something that you would want to cover. Coating systems that you might want to consider and how they're going to be used. Design geometries, what you might want to do, what you might want to avoid. What environment are you in, or even can you change the environment in order to affect a more corrosion resistant system. And then lastly, what do you need to put in your finish and process specifications so that everybody's on the same sheet of music within the program on how to implement these characteristics or desired characteristics from a corrosion prevention and control standpoint. So from that standpoint, we've got two major aspects of a corrosion prevention control program outlined in the corrosion prevention planning guidebook, the program management and ILS, and the technical considerations and design. How about other questions? Gentleman right there.
What is a corrosion prevention action team, and what does it do?
The corrosion prevention is key to the planning and executing of your corrosion prevention control program. The role of that and when to establish it is that you need to have it early in the program. Earlier the better. You don't want to wait till pretty much all the design decisions are made before you get your corrosion prevention action team up and running, because it's got to be active right from the beginning. So what are the areas that it would be active in? It's going to be looking at design. It's going to be looking at the engineering. It's going to look at the material selections. It's going to be active in establishing and monitoring the testing programs. Production, it's going to be watching for manufacturing processes that are important to corrosion prevention and control. And it's going to be looking at sustainment. Now, all of that entails costs and documentation, and they're going to be involved in all of that. They'll be interfacing with the contractor corrosion team once it's established. Once a contractor is selected, they will be involved directly and intimately with the contractor corrosion team, or the CCT. And you're trying to make sure that the CCT is actively attaining the goals of the corrosion prevention control program that you as the CPAT have established for the program. So you're going to be evaluating, not only working with your CCT, but you're going to be evaluating the adequacy of the contractor's CPC efforts. Now, we all know that many of our systems stay in the field for a long time. So one of the other key things that the CPAT does is review and make sure of the accuracy and sufficiency of the maintenance manuals that are going to be out in the field for assuring that the corrosion prevention and control program continues into sustainment. Now, from time to time, the program manager is going to need some advice about trade-offs that are happening within the program. And sometimes you're going to trade off corrosion prevention control. He needs the CPAT's advice for risks and for opportunities. So you'll be in direct interface, or should be, with the program manager. And lastly, if there's any kind of discrepancies, that they review those and try to take action on those on behalf of the program, no matter where in the life cycle of the weapon system.
More questions? You there in the front row.
Who should be part of my corrosion prevention action team?
The membership on a CPAT team can be very flexible, but there are certain key members that will probably have to exist for most all CPATs. First, the program engineering and support group should be the ones that actually chair the CPAT. So since they belong to the program office, and that's the office that's responsible for making decisions relative to the key design and materials issues of the system, they really need to chair that. They are also, that chair position is the one that would elevate recommendations up to the program management. Each of the services has a corrosion office, and that corrosion office should have a member on that corrosion board. Likewise, you will need subject matter expertise. Now, the subject matter experts can come from a lot of different places, but generally they will come from at least that services laboratory which handles the research and development for corrosion in that service. Likewise, you would have a member from the using command. Often in the acquisition phase, the users don't get involved real early in the program, but in this case, you really do need user representation from the very beginning of the board, because those users tend to have an eye on problems that they've already experienced, and they bring that historical base into the board. Then finally, we would need somebody from the test and evaluation organization, because remember, when we first get test assets out in the field, they are likely to be the initial people who will see likely corrosion problems. And then once the contract is let, we will obviously need member or members of the contractor corrosion control team.
Sir, in the hat, you have a question?
If I could go to just one place to find out how to develop and use a corrosion prevention action team, where would that be?
Well, I talked a little bit ago about the corrosion prevention and control planning guidebook. That's probably where I would send you first, which is on www.corpsdefense.org, or soon to be www.corpsdefense.gov. I'm going to talk about the guidebook a little bit more detail, kind of outline what it's like. It has 3 volumes in it. The first volume is on equipment acquisition, the second volume is on equipment sustainment, and then the third volume is on infrastructure. Let's talk about volume 1 for a moment. I talked a little earlier about a diagram, and from that I used the 2 key aspects of the program, that being program management and ILS, and the technical considerations and design considerations. That diagram is in volume 1 and kind of outlines how the document is formed. In the 3 chapters in volume 1, you have that overall description. You have more detail about the program management, ILS integration, and how to set your program management up on a corrosion prevention control program. And then the technical and design considerations. So those are the 3 chapters of volume 1. And then added to that, there are 6 appendices, having there such things as a guideline for design considerations on aircraft systems, aerospace systems. Another for naval systems, for instance. It has CPAT charter examples in there. So you have in that what you need for the equipment acquisition. That's in volume 1. Volume 2 takes you into equipment sustainment. In there are 2 chapters and 1 appendix specifically targeted at where the system is going to be for most of its life cycle, in sustainment. Now, the 3rd volume is for a very important area, infrastructure, having to do with buildings and roads, bridges, water towers, pipelines, etc. There's 3 chapters in there, somewhat like volume 1, and 6 appendices. which guide you on how to develop a corrosion prevention control program that's specific for infrastructure type of items. And then at the very end, there are 6 general attachments. For instance, metrics. What kind of metrics could you use in measuring the progress and efficiency, effectiveness of your corrosion prevention and control program? So 3 volumes: systems acquisition, systems sustainment, and infrastructure.
Yes, sir. I think the one, you in the hard hat, you had your hand up a few moments ago.
What is a contractor corrosion team, and what exactly does it do?
The CCT is pretty important because that is going to be the action body within the contractor to assure that the corrosion prevention control program is activated throughout the entire contractor and vendor infrastructure. Their primary function is to ensure that adequate corrosion prevention and control requirements are planned and implemented in all phases of the system life cycle. Now, the CCT normally won't stand up until you get contract award. There's nothing to prevent it from being activated earlier by the contractor, but certainly by contract award at milestone B, you're going to want to have your CCT in place. They have quite a few things that they're supposed to do within the contractor infrastructure. They should be there to sign off, for instance, on production drawings. How they're going to produce something is very important. They'll be looking at design reviews, providing any clarification that's necessary for program managers or engineers or production managers on issues they might see with respect to corrosion prevention and control. If there's any differences in technical solutions, they will try to adjudicate on those as to which would be best or what can be what should be traded off vice another performance parameter that they have to evaluate. Again, approval of documentation. I'm not saying recommendations or review. I'm saying they should be involved in the approval of the documentation that drives the design and production and sustainment of the system. Now, we know that an awful lot of our systems are subcontracted out. Many of the parts of our systems are subcontracted out. So the CCT should be actively involved with the contracting or the material contracts department to define what has to go into those material contracts to buy from the vendors what's required of the system from the standpoint of corrosion prevention and control. Very important that they be very active in those contract and subcontract actions. Now, what membership? It's a little different than what you have in a CPAT because of the type of people that are involved in designing and developing, manufacturing and fielding a weapons system. First of all, you're going to want representatives from the system integrated product teams, those that are designing the subsystems. They need to be involved in this CCT right from the beginning. You're going to want materials and processes or M&P engineers right up front to define some of the requirements and then watch how they're being implemented throughout the program. Your operations and manufacturing personnel and management need to also be part of that to make sure that on the floor things happen the way that they're supposed to happen, the way they've been defined in the corrosion prevention control plan. QC and QA, they need to have an influence to make sure that at the right points they touch the product to make sure that the quality that they're looking for is there and it supports a good active corrosion and prevention and control program. Your materials and subcontracts, we talked about that earlier. Those procurement personnel need to be involved in it, and of course anything that has to do with contract needs contracts personnel in there. So those are really the kind of the key aspects of a contractor corrosion team or a CCT.
Can you explain what a corrosion prevention control plan is and what is in one?
The corrosion prevention control plan is the pivotal document in a corrosion prevention control program. It guides the whole program. It establishes the entire corrosion prevention and control program and the management approach. It talks about membership, it talks about the organization, who should be involved, responsibilities, the processes that are involved in running a life cycle corrosion prevention and control program. It documents the corrosion-related requirements, design requirements, technical considerations. So again, going back to establishes the management and it derives the technical considerations and design. So all that's embodied in your corrosion prevention control plan. It'll identify the materials you need and the CPC products that you're going to use in design, manufacturing, and maintenance. When to establish it? Well, as early as possible is the right answer. As a minimum, it should be pretty firmly in place by milestone B, by the time you go into development. Again, you can go back pre-milestone A to implement it and put it in place. Even in rudimentary fashion, it would be very helpful to have it in place very, very early, but no later than milestone B. You want it in your contract actions before you establish and release the RFP or the request for proposal. You're going to want that corrosion prevention control plan in place. So again, before milestone B is absolutely the latest you want to have it in. Now that doesn't mean if you don't have one in your middle of a program and you don't have one yet, doesn't mean you shouldn't establish one. Establish the plan at any time you can, but milestone B is really the first real key, gotta have it, a milestone. Now after contractor award, you're going to turn over the corrosion prevention control plan to the contractor corrosion team. They're the ones that are going to maintain it after that. Before that, obviously, the program office is taking care of your CPCP, but you want to turn it over to the CCT after contract award. Now, you don't want the corrosion prevention action team should not release approval authority over the corrosion prevention control plan. Even though the CCT is maintaining it through much of the rest of the life cycle, the program office should never relinquish the approval authority from the corrosion prevention control plan. It should continue to be revised as the program matures, as design decisions are made, as material selections are made. You're going to want to you're going to have to evolve the plan. And once you get into sustainment, you're going to do things such as modifications. New technologies may come out. So you're going to want to continue to keep that a living document. And the CPAT has to watch over that along with the CCT to make sure that those changes get made.
Any other questions? Yes, sir, you in the back.
How should I know what I should be doing in my corrosion prevention control program and when?
Actually, that's a very good question because sometimes it's just difficult to know what to do and when to do it. Let's start with DOD 5000.1. There's a diagram in there about the phases of a weapon system development, starting with concept refinement, then technology development, et cetera, on out. If you use that, then you can kind of insert the points at which you should do some of the major things with respect to your corrosion prevention control planning on a program. First thing I think we've talked about early is get your corrosion prevention action team in place as early as possible in a program. They should actively then be involved in developing the corrosion prevention control plan for the life cycle. Even at the beginning where it might be an initial, more of an outline, kind of some general guidelines on corrosion prevention and control such as the concept refinement phase, you want to go ahead and get it in place as early as possible. Again, earlier we said no later than milestone B, but certainly as early as possible, even prior to milestone A. Through that entire process, as you go through your milestones, you should be maturing your corrosion prevention control plan. Eventually, you're going to make a contract award at about milestone B for the development and manufacture of your system. At that point, you'll develop your contractor corrosion team. Your plan will then move over to them. They will evolve it and keep it a living document, with the CPAT still being actively involved in managing the program. That should evolve right on into the sustainment and operations phase of a system development. So in general, you can find the specific areas that you need to be active in. And there'll be things like preliminary design reviews and critical design reviews and production readiness reviews, where the CPAT is going to want to be active in making decisions about the design and production and sustainment of the system. So that kind of gives you, using the 5000.1 construct, where and when you should do some of the major things with respect to your corrosion prevention and control program.
More questions? You there in the front row.
How best can I get my corrosion prevention and control program institutionalized?
That's a great question. I'll tell you, the first thing you need to do is get your leadership behind it. Without the leadership endorsing the program and backing it, watching it, monitoring it, making people accountable for it, it'd be very difficult to have a successful program. Now, that said, to really institutionalize a corrosion prevention and control program, you need to get it into the documentation. You need to get it into the normal processes of an acquisition. So start at the beginning with your users on the requirements documentation. Through the JSIDS process, any of the documents that come out that establish the requirements for the program, try to get corrosion prevention and control as one of the things that it focuses on. It's a key performance parameter and characteristics for the system. You want it to have corrosion prevention and control. The next thing you can look at is maybe the acquisition program baseline, or the APB. Getting the corrosion prevention control aspects of the program embedded in there, if not directly, at least in some of the metrics, cost, or performance parameters, et cetera, that are being measured within your acquisition program baseline. The acquisition strategy, as you get ready to compete the development, DFARS requires that you address corrosion prevention control in your acquisition plan. Take it throughout your entire acquisition strategy, and your down selects, your selection criteria for when you get to source selection. All of that comes together to make up your acquisition strategy. Your systems engineering plan is a perfect place to make sure that corrosion prevention and control is embedded. It needs to be tied into systems engineering. How you're going to engineer the program throughout the systems engineering process is where you're going to make the biggest impact on the eventual design and sustainment of the weapons system. So definitely affect the systems engineering plan. We've talked about the CPC plan itself. Make sure that's a well thought out process that's documented, and that you got all the technical aspects of the program that you desire in the CPC plan. Your request for proposals, your contracts, make sure they're well embedded in that. Make it very clear to the contractors that you're dealing with that corrosion prevention and control is a key part of your program, and it's an emphasis area for you. Because it's an emphasis area, think about award fee plans. Make sure that you put corrosion prevention control in your award fee, and it'll change over time as the program evolves. And of course, to make sure that they're doing the right things, look at the performance specifications. In particular, pay special attention to process specs and finish specs to make sure that the corrosion prevention control aspects of that part of the program is well documented for your contractors and those that are going to contribute to your program. So that's, if you want to institutionalize it, focus on your leadership, and they get it embedded in the documentation and processes within your acquisition program. You have a question? You in the hard hat?
Has the Corrosion Policy and Oversight Office specifically studied and documented some lessons learned on corrosion prevention and control programs?
Yes, we have. That was pretty important to us to be sure that if we did all the things we were supposed to do, we needed to define whether or not that resulted in a corrosion-free weapon system. We looked at numerous DoD programs across all of the services that we felt like had done all of the things that were outlined in the guidebook. And then we looked at what did go right or what didn't go right in terms of the product that was actually put into the field. And there were several lessons we learned. One of the things was that if there are no specific corrosion requirements originally up front, then it's not likely that you will have an adequate corrosion program within that weapon system as a whole. In other words, you need to get corrosion specifically defined and required in the initial capability documents for that weapon system. That's very critical. And without that, you're likely to have failure in the program. Secondly, even with the guidebook processes in place, sometimes program offices will defer those corrosion decisions, those design decisions, until later down the road. Sometimes it's the pressure of other things happening. Sometimes it's just people don't want to make those decisions up front. If those initial design decisions are not made initially, and if they're deferred, the corrosion of that system will not be as robust. And then finally, many of the programs we looked at we found that they abdicated responsibility for corrosion prevention and control to the contractor. The program office itself was not active in the design decisions that were needed, and the contractor pretty much did whatever they thought was all right, and nobody in the CPAT challenged those decisions when they were not the best decisions. So those were some really important lessons learned that we found when we looked at various programs.
And a question from the gentleman in the red tie.
Where can I find lessons learned from previous corrosion prevention and control programs so I can improve and execute my CPC?
Okay, yeah, we've talked about a few of those, but let me get a little more succinct about it. The first place I'd tell you to look at is the Corrosion Prevention Control Planning Guidebook. Again, I've talked about that earlier. It's a wealth of knowledge. It's embedded in the documentation that can give you some practical solutions and suggestions on how to develop a corrosion prevention and control plan, and how to execute your program from the point where you've done the planning. Now, beyond that, you can contact the Department of Defense Office for Corrosion Policy and Oversight. They certainly can help guide you toward lessons learned and others that have more lessons learned. The Corrosion Defense, Core Defense website is a great resource to go to. There's lots of documentation there. There's examples of how people have done it in the past. There's lessons learned. Lots of information that's on www.coredefense.org, or soon to be www.coredefense.gov. Inside your service, there are corrosion organizations that focus on prevention and control, working technologies and development to help corrosion on programs. They're there to assist you. If you go to the guidebook or you go to the website, you get the most current points of contact within your own services. So look at the guidebook. If you wish, call the Corrosion Policy and Oversight Office, get a hold of your service organization, or check out the website. So there's lots of places you can go to get additional help.
Are there best practices I can use in developing and executing a corrosion prevention and control program?
There really are a lot of best practices, and this is going to be you ask a question that's going to have a bit of a long answer, but it's a very important question, and so we probably ought to really look at that in detail, because it's the question, really, the answer to which is the difference between a program that does all the right things but doesn't necessarily achieve the results and achieving the results we want. There are multiple categories. One, we've mentioned requirements. So I want to talk about best practices and requirements. I want to talk about planning. I want to talk about activities and actions. Commercial off-the-shelf buys happen to be a unique thing that we need to talk about. And then there's testing, and then there's personnel resources and training. The first is that of requirements. The requirements initially must be in the system up front, as Carper said, as I've said. If you don't have the requirements for corrosion spelled out specifically, they need to be in the capabilities documents, the initial capabilities documents for that weapon system. So if you don't have that, you go back to your user and you say, we need help, you need this corrosion in there, please put it into your required capabilities. So that's the way you do it. The other lessons learned on requirements are that you cannot get effective corrosion requirements out of derived requirements. They must be explicit and they must be clear. For instance, a lot of derived corrosion requirements come from the life of the system. So if you've got a 30-year system, somebody derives the corrosion requirement rather than spell it out. Likewise, you could use the maintainability, reliability requirements to say, oh, well, that means corrosion has to be real good. But if you do it as a secondary requirement, you'll never get what you need. Okay, the second is into planning. One of the things that people, particularly if they're unsure of themselves, will often default to boilerplate corrosion plans. And boilerplate corrosion plans are maybe good to get started, but all corrosion plans need to be tailored to your specific weapon system and its unique requirements. Also, just to put some teeth into this, you really need to have your corrosion prevention and control into the source selection criteria. And the corrosion prevention and control plan needs to be a required deliverable document. If you don't have this prevention and control plan as a required deliverable document, then that leaves the door open for changes to be made later without any government oversight or control of it. Contractors also control changes that are made that affect corrosion design and the materials. A CPAT needs to be very involved up front in the planning, and if a CPAT independently reviews and analyzes contractor recommended changes, then if there's resistance to those things, that CPAT needs to be very involved in resisting things that would be negative, because early in a program there's a lot of trade-offs. So in that upfront planning, that really needs to be considered, particularly the trade studies. I can't emphasize that too much. The CPAT needs to be sure that a program manager has an honest trade study that they've done a thorough analysis on, so that when things are traded, that they're traded effectively. In the area of corrosion prevention and control activities and actions, as I say, the trade studies are important. It's also very important, one of the lessons we learned is to have detailed minutes. And here's the reason for that. Oftentimes program managers realize that the contractors don't deliver a corroded weapon system. Those weapon systems only corrode down the road several years. So it's not an immediate concern. So there needs to be accountability for decisions. If we don't have detailed minutes, then and a recording of what's going on, then oftentimes there's no accountability later on and there's no seriousness now. But if there is detailed minutes, then there can be accountability later, and people tend to take these immediate decisions more seriously. Likewise, the other thing that's very important is to consider the sustainment phase of the system. Remember, we've been talking primarily acquisition here, but oftentimes we fail to remember that in the sustainment phase is where most of the corrosion costs will actually be considered. So the system should consider corrosion as a part of the integrity program from the very beginning. Now, corrosion prevention and control in commercial off-the-shelf systems, it becomes a little bit more interesting and complex. Many times if you're buying a commercial off-the-shelf item or system, you say, well, it is what it is, there's nothing we can do about it, so we just take whatever we get. But that's not true. First off, where possible, if you've got competing commercial off-the-shelf systems, require corrosion testing up front of those systems. Now, I know if you're buying a complex system, you're not going to do corrosion tests. But if you've got a fairly simple system, if you're buying parts or subsystems, oftentimes you can do corrosion testing before source selection, so you have some basis for making a selection relative to corrosion. Also, again, make the corrosion documents deliverable so that the government has control of any subsequent changes. So even if you're buying a commercial off-the-shelf item, if you have those documents as deliverables, then there can be no changes once that's selected. Otherwise, as the commercial item changes down the road, whatever we're getting through the system may change without any control. If you're buying aircraft systems, it is very important to remember, do not default to FAA corrosion requirements. The FAA or commercial corrosion requirements often are far less robust than those required for military systems. When we do corrosion testing, in a lot of systems we found default to MIL Standard 810 testing. Now, MIL Standard 810 is the military standard that defines testing. However, in that very Military Standard 810, it says that these are general corrosion test requirements. They are not adequate for any specific system. So every specific system has to define its own unique corrosion test requirements. If you just default to MIL Standard 810, you will definitely have deficient test requirements. Where possible, use outdoor exposure testing. And I'm sure some of you that are here that have had experience with corrosion testing in real systems say, oh no, we can't do that because it would take too long. That's absolutely not true. Accelerated laboratory testing often takes almost as long as outdoor exposure testing. If you get outdoor exposure test coupons prepared early in your program, in 6 months, you can have good indications that are much more robust than accelerated laboratory testing. And if you're going to do outdoor testing, if possible, do realistic induced damage. And then you'll have some yardstick of how your system will actually perform in the field. For instance, even with testing of paints, you scribe the coupons. Well, likewise, you can use built-up subsystems and induce similar but realistic damage. And then the other thing that you can do, here's a place where you can also take advantage of now derived requirements. If your system has a 20-year life or a 30-year life, a lot of times you can do derived requirements that require corrosion testing to support that lifetime. Okay, and lastly, in testing, use life requirements. Here's a place where you can take advantage of the lifetime derived requirement. If you have a system that specifies a lifetime, then you can do corrosion testing to verify that lifetime. So that oftentimes will add some robustness to your corrosion testing itself. And finally, in the area of personnel and training, often, as we mentioned earlier, when these programs start out, you don't have anybody that's really trained or prepared for corrosion. So what you do is you say, hey, this is your job, you know, it's another duty is assigned. But you really do need manpower dedicated to, in that program office, to the corrosion job. And that person needs to be trained. People that are responsible for the chairing the CPATs need to have corrosion training. They can have this workshop training. There's a continuous learning module 038 that explains corrosion. It's a good place to start if you're new in corrosion and don't know much about it. That's a good source of information. There's the website. So you do need dedicated manpower from the beginning in the program office for the corrosion job, and you do need that person to have some, at least initial training to begin to do that job. So I think that would tell you some of what we've found that are good practices.
Can you sum up where I can go to get further assistance regarding my corrosion prevention and control program?
A really good concluding question. First place I would go is to the Corps Defense website. That's www.corpsdefense.org, or in the future, www.corpsdefense.gov. That's the first place, because there is the repository for so much knowledge with respect to corrosion prevention and control programs, points of contacts, documents, regulations, everything that you might need with respect to developing and sustaining a good corrosion prevention and control program. Don't be afraid to talk to your service corrosion office. They've got a lot of experience. They're involved in corrosion on a day-to-day basis, have a great wealth of knowledge, and can always steer you some additional resources that might help you. You can always give the OSD office for corrosion policy and oversight a call, and they can guide you to who or what you might need for your specific needs. All the points of contact that you need are on the Corps Defense website, are in the back of the guidebook. They're updated regularly, so please take advantage of that website. I guess our concluding remarks would be, this is a big problem. Right from the beginning, we talked about how important this is.
Over $20 billion annually.
1/5 of the maintenance on all of our systems is due to corrosion. We have to be active in correcting that problem. We have mandates that we all need to be in compliance with, not only because it's the right thing to do, and that it's required, but that it will serve us all into the future. Those that are out there, the airmen, the sailor, the troops, the Marines that have to take care of these systems and keep them flying, keep them safe, and keep our taxpayers happy with the fact that we're doing good things for the systems that they allow us to have. And I think Dan has some concluding remarks as well, don't you, Dan?
As we just learned, corrosion has gained a foothold within our nation, but we will not let it win the war. Billions of dollars are spent each year combating this menace. But let me say that we will overcome. We will turn the tide in our favor, and this electrochemical invader will cease to plague equipment, resources, and infrastructure. So, my colleagues, and I hope you have gained insight as to why the Corrosion Prevention Action Team is so important in developing a way forward. Corrosion prevention is not the most important item that the Department of Defense manages, but it is an extremely important one. Still, it must compete with all the other planning requirements so that the decision makers can make the best possible choices. These are important elective measures that support military readiness, safety, the logistics footprint, and cost associated with equipment, systems, and infrastructure. I implore you to listen, react, and use all available resources wisely. Rust never sleeps.